Welcome to MRU E-Learning powered by Malla Reddy University. I am Dr. G. Vasavi, Associate Professor with the Department of Cybersecurity and IoT, School of Engineering, Malla Reddy University. Today, I am going to discuss about the technique of backtracking in the subject of design and analysis of algorithms. So, design is nothing but the way of writing an algorithm and to find solution for a problem. So, there are predefined design techniques such as divide and conquer, greedy method, backtracking, dynamic programming, and branch and bound. So among all these techniques, backtracking is one of the efficient method which has large number of applications. For any given problem, we are having one single solution. So if any problem is required to have more number of solutions, so we are going for the technique of backtracking. So the problems which deals with searching for a set of solutions or to find an optimal solution satisfying some set of constraints can be solved with the help of the technique of backtracking. So in backtracking, the solution will be expressed as an n-tuple vector which is represented as x1, x2 and so on, xn, and where each xi is taken from some finite set xi. So often the problem is to find the maximization or minimization by satisfying some criteria function. In order to find solution for a problem, we require to satisfy two different types of constraints. So one is implicit constraint, other one is explicit constraint. So explicit constraints restrict the value of each xi to take the values from a given set, where each xi is either greater than 0 or it is 0 or 1. Implicit constraints which specifies the rules which satisfies the criteria function. So there are many applications of backtracking such as n-queens problem, sum of subsets problem, graph coloring and Hamiltonian cycles. So let us discuss about n-queens problem. So the problem is to place n queens on an n by n chessboard such that no two queens are attacking. So that is, they should not be placed in a same row, same column as well as same diagonal. So for an example, to solve the n queens problem, we are going to consider 8 queens problem. So which has to be placed on a 8 by 8 chessboard by placing 8 queens on different rows, different columns as well as different diagonal. So this is one of the solution for a 8 queens problem where you can see all the queens are placed in different rows, different columns as well as different diagonal. So for every problem, we need to consider explicit constraint and implicit constraints. So explicit constraints indicating each value of xi which is taken from the set S which consists of values 1 to 8. So each of the xi is assigned a value 1 to 8 and implicit constraints states that no two xi's must be the same. So this is one of the solution considered. Here in backtracking, we solve the problems with the help of the tree organization. So in order to implement 8 queens problem, it is difficult. Hence, we are going to generate a tree organization for 4 queens problem, where it is also called as state space tree or the solution space, where we are going to generate a tree organization in which the nodes are numbered according to depth first search. So as we can see in the tree organization, we are having the different possibilities. So for example, we are going to consider a 4 by 4 chessboard for solving 4 queens problem in which the queens has to be placed on different rows, different column as well as different diagonal. So here, while placing the first queen, we are having different possibilities that there are 4 options available. So which indicating xi or x1 is equal to 1, 2, 3, 4. Hence for the root node, it starts with the 4 possibilities for assigning a value for x1. And similarly, after placing x1, there are only 3 options available for placing x2. Similarly, 2 options for placing x3 and only 1 option left for placing x4, that is queen 4. So this is the way how we have numbered the nodes according to depth first search and applying the implicit constraints where no two xi's must be the same. So this is one of the partial solution generated by backtracking. So initially, we are going to apply the technique of backtracking where we consider first one path and we try to find solution using that path. If that is not possible, we go for the next alternate path and continue until all the solutions, all the paths have been completed and finally the solution is being attained. So here, this is a partial tree organization generated for 4 queens problem using backtracking. So here, how we have obtained this portion of backtracking. So initially, we have a 4x4 chessboard. So where we are going to first place a first queen. So if you are going to place a first queen in the first location or the first column, so where x1 is equal to 1, and then this is your first path that is to be obtained, and we try to find whether the solution is obtained. So after placing the first queen in the first column, so there are 3 options left out for placing the second queen. So we try to put the second queen in first second row, then as it is in a diagonal, so we try for the next one, so queen 3. So here we can have when x2 is equal to 2, we are backtracking, that is we are not able to place a queen in the second column. So we go for the next path, that placing the second queen in the third column, and we try for it, and then later we also try for placing of the second queen in the fourth position. Now we need to place a third queen, so we cannot place x3 is equal to 1 or 2 or 3 and then finally 4, indicating that there is no possibility of placing the third queen by considering this particular path. And after that, we try to place the queen in the fourth location, the queen 2. Then we try for placing the third queen in second location. Finally, there is no option to place for fourth queen, and hence stating that the path we have followed by for placing the first queen is not possible to place all the 4 queens on a 4x4 chessboard. Hence we go for the next path where we are going to place the first queen in the second column. So placing of the first queen in the second column, we have 3 options for placing the second queen. So if we are placing x2 is equal to 1 or x2 is equal to 3, so that they are both the queens are on the same diagonal, hence your path for backtracking stops, and we are going to place the second queen on the fourth column. Hence the queens are not in a same diagonal. Next go for the placing of the third queen, where we can place in the first column which satisfies the criteria that the queens are non-attacking. Finally, placing of the last queen, we are able to place the last queen in the third position, hence satisfying the criteria that all the queens are in different rows, different columns, as well as in different diagonals which are non-attacking. So this is a portion of a tree, that a state space tree, which is being generated, and hence this is one of the solution obtained. And similarly, we can also find out the solution by taking x1 is equal to 3, where we get another solution, and when while placing x1 is equal to 4, that path also will not lead to an answer state. So here, for the given problem, we are having 2 different solutions obtained. So similarly, we are also having the other problems like sum of subsets, graph coloring, as well as Hamiltonian cycle, where for every problem we have more than one solution existing, and by using the technique of backtracking, we generate the tree organization, and then all the possible solutions are being obtained. So this is the advantage of using the technique of backtracking, where all the possible solution states can be achieved by the help of backtracking, where the tree organization is being generated with the help of depth first numbering of the nodes, and it is one of the technique which is more efficient for finding an optimal solution. Thank you.